Alright, part 2 of graph features of polynomial functions. In this part there are going to be 3 objectives. I'm going to do the first 2 objectives in this video and then work with the third objective in a different video. So the first objective states that you should be able to determine the intercepts with multiplicity, and again this is based off of if you're given a graph of a polynomial function. And so the goals when working with this is to recognize x-intercepts and what even or odd multiplicity makes the graph do at that intercept or root or solution. And objective 2 is then from the multiplicity or the intercepts you find with multiplicity, you should then be able to write the polynomial in factored form based off of the x-intercepts. So goals to consider when working with that: understand the relationship between the x-intercept, root, 0, solution, all the same thing, and the factored form of that x-intercept. And then understand the relationship between the multiplicity in objective 1 that you find and then the power you use for each factor. So some key terms, or looking more in depth at some of these key terms before we show an example. Multiplicity, what that means is how many times that specific solution exists. And then there's 2 different situations that can happen. That solution could have an even multiplicity, and that means that it's bouncing off of the x-axis, versus the second situation could have an odd multiplicity, means it goes through the x-axis. It's all based off of the x-axis because we're talking about x-intercepts. And so let's look at this example really quick to put multiplicity more into regular terms and show you a little bit more about what I mean. I broke it up into root and factored form because that's another part of this objective, being able to go from root to factored form. So if I look at my graph, I need to look at x-intercepts. And again, x-intercepts are where they cross the x-axis. And so I see cross or bounce off, hit the x-axis, let's say that. So I see 1, 2, 3 places where they cross or hit the x-axis. So I'm going to say for my root form or solution form or x-intercept form, x equals -5, x equals -1, and x equals 2. Now, what happens when at -5 it's coming down and it bounces off of there? So whenever it bounces off of the x-axis, it is an even multiplicity, and in this case, for this purpose, we're going to say it has a multiplicity of 2. So I'm going to say multiplicity of 2, and I'm going to use multiplicity, I'll put that up here, with the letter M, denote it with the letter M. So this is going to have multiplicity 2 because it bounces and it's even, and I know that it's even because it bounces off the x-axis. This one, -1, goes through, so it's going to have an odd multiplicity, and for these purposes, we're just going to use multiplicity 1. It could have multiplicity 4 or multiplicity 3, it just has to be even or odd, and we're just going to use 2 and 1 for this objective. And the higher the multiplicity, it just looks different at that point. The graph would look a little bit different. And then finally over here, it bounces again, so it's going to have an even multiplicity, so it'll still be multiplicity 2. So to actually write that out then in the answer form that I want to see if you're trying to find roots or solutions, you would have x equals -5 with a multiplicity 2, meaning technically that in this point x equals -5 twice. But we don't write it like this, we're going to write it with the multiplicity of 2. And then at x equals -1, it goes through, so it's an odd multiplicity, so that means it's multiplicity 1. And then finally, at x equals 2, it is multiplicity 2 because it bounces. So that is root form, the solutions that I found with its multiplicity, meaning even or odd, multiplicity 2, multiplicity 1. And that's how I want you to write this, using a lowercase m and then however many times it shows up, either 2 or 1. Now in factored form, the relationship between multiplicity and the root in factored form is that multiplicity means how many times the factor shows up, and we're going to denote that with a power. And so factored form, we're going to talk about this more specifically in just a little bit, is opposite sign of the root form. So it would be x plus 5. And instead of writing multiplicity 2, I'm going to put to the power of 2, meaning that factor technically shows up twice, x plus 5 times x plus 5, if you were to write out this polynomial function. But you can shrink that down to just, or condense that down to x plus 5 squared. Down here, it's x plus 1, and it's multiplicity of 1, so I can put the power of 1, but remember, whenever it is power of 1, you don't necessarily have to show that. And then down here, it is x minus 2 with a multiplicity of 2. So that is more specifically what I mean by multiplicity when we're going to be working with that. How many times the root shows up, and I write it like that, versus how many times the factor shows up, and that's how I want to write it as well. Now, to gain a little bit more practice going from factor form to root form, or vice versa, because this skill is very necessary, when you've identified roots here on a graph, you're eventually going to have to be able to write them in factored form. So that skill going from root to factored form is very necessary. Let's practice these 6 situations that I've given you here. I've given you factors 1, 2, and 3, and then roots down here 4, 5, and 6. So if I'm given the factor of 2x squared, I need to find the root. And I know that a root is going to be x equals something. The difference between a factor and a root is that roots have an equal sign, because you're actually trying to find out what x equals. Factors have some type of operation happening to the variable, whether it's multiplication here, subtraction there, or addition there. So I need to find out, again, there's 2 ways to think about going from factors to root form. What makes this factor 0? So what number can I put in for that x to make that factor 0? Or I can actually set the factor equal to 0 and solve. So if I divide by 2 to get x by itself, that cancels out, divide by 2. So now I have x squared equals 0. 0 divided by 2 is 0. Then to get rid of the power, I take the square root, x equals plus or minus 0, or just 0. The square root of 0 is 0. So my root of this factor is 0. But I'm not quite done yet, because this has a power of 2. And if you remember from up here, if a multiplicity of 2, it goes to the power of 2, and vice versa. It works the same way backwards. So I write 0, multiplicity 2. And now I'm done. So in this particular factor, that 0 shows up twice on the graph. So it would bounce off of the x-axis at x equals 0. Now moving on, x minus 4. I can ask the same question, what's the only number that works, where if I were to put it in for that x, it would give me 0 for that factor. Hopefully you can think that x equals 4, because 4 minus 4 is 0. If not, it's the same process. I set it equal to 0 and solve. I have to add 4 to both sides to get x by itself, so x equals 4. And in this case, there is no power listed. So if there's no power listed, I can assume that it's 1. So that means that this is multiplicity 1. So go ahead and try number 3. So pause the video here and try number 3. So give me the solution. X equals a solution with its multiplicity. Hopefully you've paused the video and you've tried this on your own. So the answer you should have gotten is x equals negative 2 with a multiplicity of 2. If you didn't get that, please raise your hand so I can come check your work. Now, same process going from roots to factors. I've been given 3 examples of roots. I need to bring it back to factored form. And so it's a little bit trickier, but you just have to consider what is the actual root. In this case, it's x equals 0 with a multiplicity 2. So it can look a little different. I just mainly care about the variable. So I know the factor has to be just a lone x or a number being multiplied with an x because of this process up here. So if I say it's 3x, I'm not quite done though, because this multiplicity 2 means I need to have a power of 2 there. And so then I'm done. It could be that factor. It could be something else similar to that, but that's perfectly fine for this example. And then down here, x equals 2, so it's a number. I know that the factored form is the opposite sign, and so it's a positive 2, so I know the factored form would be x minus 2. Because again, the sign switch, when I went from factored form to root form, let's say up here it was an x minus 4, so it became x equals 4 because of this math over here, so it was a positive 4. So the signs switch. And I'm almost done, and this is a multiplicity of 1. So I can put 1 up here, but again, if it's 1, I don't necessarily have to either. And so go ahead and try the next one, and actually let's make this multiplicity of 2. So go ahead and try to give me the factored form of x equals -3 with the multiplicity 2. Pause the video and try that. Hopefully you paused the video and your answer for the factored form of x equals -3 with a multiplicity of 2 should have been x plus 3 raised to the power of 2. So you should be able to see the relationship between multiplicities and the powers. Multiplicities in the root form versus powers in the factored form, because that is a key skill, because now we're going to write the polynomial in factored form using powers instead of multiplicities. So I'm going to go back up to here, and we've already denoted the factored form here, but this is the expectation of factored form. So I'm going to have y equals my factors. I found the roots. Remember this process. I found the roots originally by looking at the graph. Here, here, and here. I've noted their multiplicities, and then I need to turn it into factored form. So from multiplicity, it turned into a power of 2 in factored form. So my first factor is x plus 5 squared times the next one, x plus 1 raised to the 1. And then finally, x minus 2 squared. When a polynomial is written in factored form, it can tell you a couple of key pieces of information about the specific polynomial. And we have been given the graph, so we could tell this from the graph as well, but I just want to show you this because we're going to talk about this in the future. If I were to multiply all this out and get it into standard form, because that's the whole purpose, to go from roots to factors to standard form, but I'm not going to have you actually do that. For example, if I were to multiply it all out, the highest power of this polynomial would be adding the powers that exist. That's why we have to find powers. And these are bases, x plus 5 raised to the 2, so when you base times base, you add the powers. So it's 2 plus 1 plus 2 equals x to the 5th. If this was in standard form, the highest power of this polynomial would be x to the 5th. And because it's 5, that means that this polynomial is also odd. If it was x to the 6th, it would be even. But it is odd, the polynomial itself. So that means that the endpoints, one end's going down, one end's going up. So odd polynomials, end going in opposite direction, even polynomials, end going in the same direction. So we're going to work on that as well. Now, last thing, and I'm going to hit this harder in the future again, but the tail of this polynomial right here, the end part of it is going down. So my final piece of information that I need to know is that this polynomial is negative. And so my final answer, if I was going to put it in a factored form, would be y equals negative x plus 5 squared times x plus 1 to the first times x minus 2 squared. And that would be how you approach that.